Chapter 13, Section 6, Exercises 3, 5, and 7. We will find the directional derivative of the function f at the point 1, 2 in the direction of the vector 3i minus 4j. I will leave the limit definition for you to read here in Exercise 3. First of all, the directional derivative is defined in the direction of a unit vector. So if the direction in which we are taking the directional derivative, v, is not given as a unit vector, then you need to define u where you unitize v. We see the result here. Again, I will ask you to read through this limit definition work. At the bottom of page 2, the page before, we have a theorem which gives the value of the directional derivative of f at the point xy in the direction of the unit vector u. This first entity we will give the name gradient vector a little bit later in this handout. Here we have the unit vector u, and we form their dot product. As you know, the output of a dot product is a real number, and that's what we expect from a derivative. Directional derivative, partial derivative, whatever. We expect a real number output, a rate of change, and a rate of change is a number. Back here to the bottom of page 3, calculating the directional derivative. Using the theorem at the bottom of page 2, we need to compute the partial derivative of f with respect to x, that's 2x, evaluated at 1, 2, we get 2. The partial derivative of f with respect to y is 2y, evaluated at 1, 2, we get 4. What I am writing now is the gradient vector of f at the point 1, 2, and we will take the dot product with u. This is the theorem at the bottom of page 2. And again, as I mentioned before, we will soon give this circled entity the name gradient vector. Our result from above gives us a gradient vector 2i plus 4j, and u was determined at the beginning of exercise 3, circled here. We get 6/5 minus 16/5 is negative 10/5, which is negative 2. That matches the limit definition value answer from above. At the bottom of page 4, here is where we give the name gradient vector to this entity. In exercise 5, we have a recap of what we did in exercise 3. Notice the position of the gradient vector. First of all, let me ask you, it's not stated here, but on what contour does the point 1, 2 lie? Well, if I plug in 1 and 2, I get a value of 5, so it's on a contour with value 5. And 5 equals x squared plus y squared would be a circle of radius square root of 5 centered at the origin. 1, 2 lies on contour with value 5, level curve value 5. Notice that the gradient vector is perpendicular to the contour. Its I displacement is 2, j displacement is 4. Exercise 7 is basically a redoing of exercise 3 from the bottom of page 3. The gradient of f at xy would be the derivative of x squared is 2x, I plus the derivative of f with respect to y is 2y. At the point 1, 2, again we get 2i plus 4j. We take the dot product of the gradient with u. Negative 2 is our answer. It would also be beneficial for you to read through the properties of the gradient found on page 6.